Hi, my name is Harry Ricker. Good morning. This is the Cosmology discussion group for November 16th, 2025. Welcome, everybody.
Hello.
Okay, so we got the recording going. James Keene is going to talk to us this morning about being careful about disclosing information. And
Correct.
so I guess we can get started here.
Okay, let me share. Where is that? Send request.
Okay. If we have time later, I'm going to, we'll entertain questions about last week's discussion on what is space. I think there were a lot of questions that really didn't get answered. I have some additional comments. So go ahead, Jim.
Okay, I'm trying to get my shared screen. If everybody arranged their icon of the participants in the right, my shared screen will be able to use the entire screen. Gosh, I can't seem to get this share screen working here. Let's see.
Well, it's not so good that you can't get your presentation. Let's see. Um,
Okay, here is, let me select this as the screen to share. Share.
There we go. It's doing something. That's good.
Great. Thank you. Okay, should I start, friends?
Well, I don't see any present. Oh, there it is. Okay, there we go.
Okay, on my blog, Independent Investigation of Truth, which is James Keene at blogspot.com, shown here in the URL. I put this article up, which is a summary of today's talk. Did DARPA rip off Keene on neural network learning artificial intelligence? So let's start with the abstract. Let's see if I can get control of this screen. Okay. In about 1988, so we're going back quite a long time here, James J. Keene, sent detailed information to DARPA. That's the Defense Advanced Research Projects Agency, on his invention of the intron, perhaps the first AI algorithm based upon neural network learning. The story developed like something from a spy novel, leading to Nobel Prizes in physics just recently this year in AI research, and billion-dollar companies like Qualcomm, NVIDIA, and so forth. So here's
Jim,
this. Yeah.
I'm kind of confused. How can a Nobel Prize in physics be given for doing work in computers?
Well, that a lot of people commented on that unusual situation, Harry, and on the internet. And in fact, it was the most recent Nobel Prizes in physics were given to two artificial intelligence researchers.
Okay, well, I'm sure, I hope that you'll explain this later. That's puzzling to me, but anyway.
Well, I mean, I think no one can understand that. Yeah. Anyway,
it is not puzzling. It's insulting us as a physicist. It's insulting.
Yeah,
okay, sorry.
that was very. I agree, Vladimir. That was a very controversial thing the Nobel Prize Committee did. They could have awarded the Nobel Prize to these particular people, but under a different category or whatever. Anyway, here's a simplified intron concept. It came actually from my work in neuroscience and so, and how neurons work in networks in the brain. So here's our intron object. It contains knowledge, which is going to be a number of numbers, and it can give out responses. These responses can go back to the real world, which is over here in this box. And the response then can be evaluated in terms of its success or failure in the real world, comparing 2 times, time 2 and time 3 here, and give feedback, that's the F item here, back to the intron to modify its knowledge base to improve through a learning process its future responses. The stimuli here, the SI, are taken from the real world, some state of the real world, something happening in the real world. We'll get down to a little more detail about this down below. So some of the ideas to have in mind at this point is we have stimuli, the response of the intron, and these introns, of course, can be put into arrays of different sorts of basically any kind of layering that you want to use in a particular application. The feedback to the intron based upon the success or failure of its response, and the improving knowledge base stored in the intron. Okay, let's stop for a moment and ask, what is artificial intelligence? How can we define that? Computer programs can automate tasks to increase productivity and exhibit a sort of intelligence. Further improvement requires, as I think everybody here knows, a human programmer to modify the program code. This automation goes back to the very first computer programs. In other words, all of us who've been using computer programs to do various tasks, these programs might be said to exhibit a sort of intelligence. Now, most computer scientists agree that a major departure from this computer automation era is systems that can teach themselves to master a task, such as the intron above. And this may be designated as artificial intelligence or AI. And so here is some definitions here of what just simple computer automation is and what intelligence it has and how it can help us a great deal and save us a lot of time. Like, for example, a program that takes input data and gives us the balance sheet for a company that an accountant might use. It could save him hours and hours of time. And so that's a sort of intelligence. But systems that teach themselves to master a task, that's sort of like a new era that we might define. It may be arbitrary or not, but let's just define it that way for now, which is going to be designated as artificial intelligence. Now, what was the Intron research program? Over some 5 or more years in the 1980s, I developed the Intron invention that could learn to perform a task successfully based upon real-world feedback on its actions, as I just described above. As far as I knew at the time, this Intron project was the first neural network displaying learning on planet Earth. The object was to trade commodity futures contracts profitably. The daily real-world data, the W in figure 1 above, was the open, high, low, and close prices of a number of commodity futures contracts. Each day, this state of the real world was presented as stimuli, S in the above diagram, to an array of introns, one for each commodity contract. Thus, each intron was exposed to all the data, W, for all the commodities monitored. These were like bonds, metals like gold, silver, copper, etc. currencies, Japanese yen, British pound, euro dollar, etc., grains, corn, wheat, soybeans, etc. Each intron then issued no response or a response R to buy or sell its particular contract at market open or close. The success of responses, the profit or loss, was then determined from subsequent data W to provide feedback, which updated knowledge in the responding intron as shown in figure 1. So the success of the responses here was fed back compared with real world events. Did the commodity price go up or down? That, excuse me, provided feedback of success or failure back to the intron to modify its knowledge base and learn the task. The human operator, that was me, had just two tasks. I only had to do two things. One, obtain from the Wall Street Journal the data daily, W, and type it in. Now, of course, today you could click on a button and download all of this data instantly, practically at the speed of light. Back in those days, you had to go, have the Wall Street Journal delivered to your door, or go out and buy it at the drugstore and go home and type in the data. Second, the human operator, after the intron array achieved net profit performance from its learning, the operator would place the buy or sell orders R to a commodities broker before market open or close. In this project, a training period was operation of the system until consistent net profits were achieved. Since real-world market dynamics could change over time, training continued after the success criteria of net profits was achieved. Intron is short for intellectron, as shown in figure 2, and presented as a physical device. In other words, back in this late 1980s period, I was already talking about making an actual intron chip with the device that would plug into the bus sockets on PC motherboards. What are the bus sockets? You might have a circuit board which is a serial and parallel port. Those would be two different devices, serial port, and you might have a socket or a circuit board that plugs in to provide interface to your monitor to display a screen. You might have a circuit board to act as an oscilloscope to display on the screen readings from oscilloscope probes attached to some circuitry somewhere. In other words, these are what we call the bus sockets on all PC motherboards. So at that time, they existed also on your typical IBM style computer back in those days. And I was proposing that there be an intron chip, and that would be on a circuit board that could then allow PCs to do artificial intelligence learning. And here is some of the features of the intron from that point of view, that there had to be inputs defining the function that it was to perform, a ready clock signal to indicate that the intron was ready to perform a new task, the feedback inputs, the response outputs. You notice some of these values are tri-state values, plus no response or minus, which would be in this case buy, no response, or sell. And here is just some of the details of how all of that was laid out in great detail at the time. In figure 2, the function inputs could select operations. In this example, 2 function inputs could select 4 functions, F sub 0 to F sub 3, input stimuli, output response, wait for response to be used in the real world, and input feedback. Those were 4 possible functions in sequence. The S, R, and F information could be tri-state, -1, 0, or +1. An enable input starts the selected function, and a ready output signals operation completion, so that everything was laid out. Okay, Intron invention sent to DARPA. Let me just add a footnote here. My purpose today is not to explain in detail the Intron. It's just to point out that this was designed and existed at the time. Intron invention sent to DARPA. In about 1988, the author sent detailed information, I'm talking about a lot of detail, to DARPA on his invention of the Intron, perhaps the first AI algorithm based on neural network learning. This information included a description of the Intron invention, design diagrams such as figures 1 and 2, and those are just 2 of many that were included, software code, the actual code itself, to implement the Intron in real-world tasks such as commodity futures contract trading. That would be the software version of the Intron, and also the documentation that of how the software Intron could be encapsulated in an actual physical chip, which could be mounted on circuit boards as indicated in figure 2 above. And lastly, 4, documentation sent in to DARPA that the Intron could learn to perform tests successfully, namely buy and sell commodity futures contract with consistent net profit. In short, the package mailed to DARPA was not just an idea, not just what might be. It was a complete disclosure of the Intron invention with a successful demonstration that anyone could grab and run with it. Many of the key documents contain copyright notice. In retrospect, it may have been a bad idea to send such a complete package to DARPA. I'll leave that statement there for future discussion. So what was the initial DARPA response? Well, we start with the men in black. Several weeks later, of course, in those days, you didn't send stuff like this over the internet. The internet hardly even existed. You sent it by mail, a package by mail with special delivery and so forth. Several weeks later, 2 gentlemen knocked on my door in the beachfront Villa Del Mar apartments in Isla Verde, Puerto Rico. I invited them in. They had questions. I was thinking, they saw the movie. Both wore black and had crew cut hairstyle. We talked about the 16-bit PDP-11 computer in the living room that I had. They wanted to know more about me, where I worked, and etc. Maybe they wanted to see if there were posters of Marx, Lenin, or Chairman Mao on the walls. Well, there were no such posters. These men in black were polite and friendly. They confirmed that DARPA had received my package. Recorded phone calls. A month or so later, my phone rang. I picked up. Hello? The caller said, I have sent over the recordings of Dr. Keene's phone calls. Pause. I replied, excuse me, this is Dr. Keene. Silent pause, hang up. In this creepy episode, the caller had mistakenly dialed my number instead of the person to whom he was sending the recordings, the alleged recordings that he said in his statement. In addition to a second confirmation that my Intron package was received, the recording of my phone calls suggests that DARPA deemed that the content of my Intron invention was important or may have some importance. Apparently, DARPA wanted to know who I knew and what I talked about. Why? Perhaps they wanted to know who else knew about the Intron project. However, at the time, I shrugged this off as a comic mistake. this is sort of funny. The guy calls me instead of the person he really wanted to call. I did not ask why DARPA might want to make me a character in a spy novel. Fast forward to 2025. The Men in Black and the comic Kohler came to mind when the Nobel Prize in Physics was awarded to two AI researchers. All you have to do is Google Nobel Prize 2025, and you'll see them right there. And they're not even physicists, they're AI researchers. Commentators immediately on the internet immediately noted an unusual classification of computer science as part of physics. Was it possible that my Intron project and DARPA was part of this story? Okay, the story of Jürgen Schmidhuber. That pronunciation of Jürgen is given by this gentleman on his own website, where he gives a phonetic way to say his name. It's Jürgen. The question of the possible role of the Intron project in AI developments requires a scholarly literature review. In an amazing and so I was thinking at this point, oh my God, when am I going to have time to do that kind of a thing, like a review to see how my project may figure in this whole story. But in an amazing coincidence, a look at my XCOM feed recently included a long post with exactly that by Jürgen Schmidhuber. And here is his XCOM handle. A German computer scientist noted for his AI work, specifically artificial neural networks. Here is his post. He's giving here in this post, excuse me, a 2025 update: who invented transformer neural networks, the T in chat GPT, excuse me, timeline of the transformer evolution in a technical note, and blah, blah, blah. Oh, okay. No, notice the 1991 date here. If you dare click on the show more, you find out that this is a huge post with a complete bibliography. And you'll find out from this post also that these guys in AI are arguing about who invented what first, and they're fighting each other back and forth. Okay, if one dares to click show more on the XCOM display in this post, a very long text appears with an extensive bibliography. If I interpret this material correctly, the first papers on artificial neural networks that learn, like the Intron invention, appear in 1991. This date allows sufficient time in which others may have incorporated the Intron project into their own work. His webpage says, in the late 1980s, Schmidhuber developed the first credit-conserving reinforcement learning system based on market principles, and also the first neural one, quote unquote. Okay, now, of course, this concept of reinforcement comes from animal learning experiments and is the feedback in the Intron that I showed above. Now, do you believe in coincidences? The Intron project was demonstrated to work in the financial markets. Huber claimed to have developed a learning system based on market principles. Did Huber have any link to anybody at DARPA? In his CV, how are we doing on time here?
You got about 15 minutes, I think.
Oh, good. So we're fine. We're getting down to the end here.
No, 10 minutes. Well, okay. Keep going.
Did Huber have any link with anybody at DARPA? In his CV, he was postdoc at University of Colorado at Boulder, in July 1991 to December 1992. He declined a postdoc offer by Caltech, it says on his website. The Men in Black story suggests that DARPA operatives can show up anywhere. Did other proverbial Men in Black look at Shu Huba's profile as a computer guy who might follow up on the Intron project information that they had? The present relevance of Schmidhuber's recent post in figure 3 above is literature citations in which the first true AI papers appeared in 1991, assuming I understand this material correctly. I replied to his post asking him, have you heard of the Intron project set by James J. Keene, PhD, to DARPA in the late 1980s, a neural network that learned to trade commodity futures profitably with complete software to do so in real-time investments. Thanks in advance for any information you may have. As of this date, I have not received a reply to this question directed directly to Schmidhuber. In my reply, I asked if he had any information about the Intron project. No reply as of this writing. Homework for internet sleuths. How might internet detectives trace who handled the Intron project at DARPA and to whom information about it may have been transmitted? Quite a homework assignment. I can only dimly see what readers might find. For example, does DARPA appear in the CVs of any of the authors of papers in the 1991 timeframe in Schmidhuber's bibliography in figure 3? I already checked for Schmidhuber. DARPA is not in his CV. Maybe DARPA links are not routinely included in CVs, for all I know. Hopefully this has been a fun story. Is there any message beyond the question of whether the Intron project was a founding participant in artificial intelligence? Yes. The big questions are integrity, honesty, and justice in how people treat each other. Well, thank you. That's my talk for today.
All right, that was fairly quick. Okay, I thought it was kind of interesting. You kind of gave us a brief overview of AI. My question is, why did you send any of this information to DARPA in the first place? Were you responding to a request for information?
No, I guess maybe I wasn't as smart as I am now. I don't know.
You just sent that off to them saying, here, I've got this interesting stuff.
Well, maybe I thought that this invention could be of service to a country, you know, being a patriot guy and so forth. I did what I did. It is what it is. And you can see I really sent the whole thing in 1 to 4 here shown on the screen now. So yeah, that's a good question, Harry. Why did I even send it in the first place?
You didn't file any patent application, did you, Jim?
No, I didn't. I did raise a very substantial amount of money. I took my package up to, I was in Puerto Rico at the time, and I took my package up to New York City and went to some of the top investment bankers in the world, you know, Goldman Sachs, JP Morgan, et cetera, et cetera. And I used I got in to speak with some of the top people in those companies without even an appointment, by simply calling up and saying, I'm only going to be in New York for a day or so. I have some important information for you. Can I drop by this afternoon? And after some scrambling on the other end of the phone, they said, yes, come in. So I could talk to some people. I raised quite a substantial amount of money to be where one of these companies set up a trading account that I had access to actually do real-time trading with it. And so let's see. So
we can blame you for all the abuses of computer training in this trading in the stock market. Is that correct?
Well, I don't know about that.
I'm being facetious.
Okay. What I'm doing now is I'm selling, my home office is selling liquidity. There's a big demand for liquidity in the stock market and for many assets. And so I provide liquidity, and that's very, very profitable. But it's not this speculative trading that we have here documented.
Okay. All right. Anybody else with comments or questions?
I mean, just following up, why didn't you attempt to register this for copyright reasons or obtain a patent on it?
Well, maybe I was just, let's see, that would be, let's say 1990. So that would be 35 years ago. That would put me in the early 40s of age. Maybe I was just a little bit naive. I did include copyright. I had read about copyright and stuff, and had put copyright notices on all of my stuff, including printouts of the software code and so forth. But I was under the impression that you can't actually patent necessarily software or what was. Yeah, maybe I just didn't have the knowledge or the sophistication at the time. I mean, after all, what can you expect of a 40-year-old guy? That's just a kid.
Yeah, I think the issue here, Ian, is I'm not sure. I think James mentioned this. I'm not sure that you can patent software. You can patent an invention, but I'm not sure what his invention is. It's a feedback. Feedback's not something that's not already known about.
Yeah, but presumably from what Jim said, this wasn't the reason that he didn't seek to patent it. You could have looked at the process, obtaining a patent on that. You weren't aware at the time, presumably, if this is so, that you couldn't patent software per se.
Well, I wasn't, and I sent the whole package to DARPA to, I guess, as a contribution to the country, if you will, or whatever you could call it, maybe naive or just a patriotic act, or that I personally wasn't necessarily that interested in making money off of it per se. Although basically the ideas therein are now, NVIDIA and Qualcomm and AMD are now producing the kinds of chips that I suggested that they produce. And
yeah, but I think you could have patented the idea of the Intron and its setup. That's intellectual property. That's not software. That's a design of a mechanism.
Well, I think Jim's mistake was not consulting a patent attorney.
Yeah, that
Yeah, probably so.
Sounds right. It wasn't until much later that my daughter actually got her law degree. So, she could tell me things that I didn't know. Yeah, so that's the story. What do you expect from a 40-year-old guy? That's just a kid,
Oh no.
I'm 80 now.
Well, that's a mistake. But you got away lightly, sending it to DARPA, I dare say, for patriotic reasons or whatever. Had you sent it, for example, to the Soviet Union, you'd probably be in deep trouble now, possibly incarcerated.
That's the point.
So the only real indication that you have that they actually looked at what your package was is this visit from two men in black.
And the phone call that they were recording my phone calls.
And other than that, there wasn't any, they didn't, okay. So I guess the question is, they probably were puzzled when this arrived and didn't know what to do with this package. Did you send it to a particular person or did you just send it to the main desk? Or that would be, in other words, unless you send it to a particular person, the question is, you got this package sitting there and somebody opens it and they go, what do we do with this?
Right. Well, if anybody that with knowledge of this situation happens to see this particular video, they might let me know who the person at DARPA who received the package and what they did with it, as far as they know. I mean, I'm not intending at this point in time to get anybody into trouble or cause any earthquakes to occur, social earthquakes to occur. But it would be interesting to find out if DARPA did spread this information to others, and the timeline seems to indicate that they may have done that.
Yes, that does seem interesting. But of course, the idea of feedback isn't a new idea. It's been around for since the 1920s, I would say.
Right, but making a neural network that learned was I don't think you had people talking about that much or at all before the dates that I've indicated in my talk.
Yeah, I can't really comment on that. I'm not really an expert on neural networks and computer technology, so I can't. I'm not sure we have anybody here that can either, other than you.
Well,
Yes.
that's why I indicated that a literature search would be an important scholarly thing required to establish some of the possibilities I have described. And it was an amazing coincidence. I mean, what are the odds that Jurgen would post this post precisely with such a literature review? His post, if you click on the show more indication, is extremely long. And it includes, among other things, a complete bibliography. He distinguishes between simple automation and machine learning, as I did in my presentation here today, in a similar way that I did. And the first neural networks showing machine learning, apparently in his bibliography, appear in about 1991. And so his analysis as a recognized worker in computer intelligence and learning, artificial intelligence, agrees with the timeline that I presented.
All right, we're gonna get cut off here. We got less than a minute, so it's gonna stop here pretty soon.
Well, thanks for your comments and listening here.
All right. All right.
Just
So
quickly, you haven't thought of contacting DARPA in the meantime to ask them, has anything happened further to your submission so many years ago?
Well, I indirectly did so with a post, with my post on x.com.
to Cosmology discussion group, November 16th. 2025. Jim, you just barely got in your answer there.
Yeah, my post on x.com that I showed you was in highlighted the handle of DARPA, and so they would have received that post knowing that I was making the statements that I was making. And well, as I was saying, a literature review would be required to really go into this. And I was just curious because the Nobel Prize was given to these two AI researchers in physics. And, it just reminded me of this whole episode back when.
Okay, a couple of comments on that. Regarding the business in physics, I don't think there is a Nobel Prize for computer science. Is that correct?
I don't think so.
Is there a Nobel Prize for mathematics?
No.
Think
I
so.
think so.
No.
No?
So that's the closest they could come. Physics, Nobel Prize in physics is the closest they could come to embracing this topic of artificial intelligence. Such what it sounds like to me.
Yes, it's correct.
But I don't think that's really physics. I think they just shoehorned it in. That would be my view of it.
Can I ask you the question about the mathematics a little bit inside of your chip? What kind of mathematics you use in your invention, in your device, in your chip? Because right now, as I know, artificial intelligence is based on multiplications of matrices. What kind of mathematics inside of your chip?
Well, the knowledge parameters were tri-state values, and the stimuli were also tri-state values and could be seen as a matrix. And so, and the feedback also were tri-state. And so that you have use of the feedback to modify the knowledge base. In other words, if an item in the knowledge array was falsely predicting, or excuse me, was predicting a response that proved to be wrong in terms of profitability, in this case, its value would be diminished, and or if it was right, its value would be strengthened a bit, and that would then help determine future correct responses.
I have a question about what is going on inside of your chip. That's it, simple like this. Because you cannot patent any idea. You had a great idea, but it's not patentable because ideas you cannot patent them. That's why you must have something real inside of your chip, because it seems to me that these Nobel Prize laureates in physics, they told that the most important part of their invention is matrices multiplication, if I understood them correct.
Well, matrix manipulation was definitely involved. Whether exactly you could say it's matrix multiplication is a question to be looked at. But yes, with each cycle of the intron, when feedback arrived, it would modify the knowledge base to better predict in the future successful responses, or to better produce successful responses.
You see, it sounds like an idea. It's a great idea. I like it very much. Thank you so much for your presentation, because I have no idea about the history of AI. That's why it's good. But what is important? How to proceed with the idea. You proceeded as a 40 years man. Don't they told us you was the boy. I'm so sorry, man. I don't believe you. I can see your character. I know your passion. You're not a boy. You never was a boy. I'm sorry.
Well, I'll take that as a plus comment. Thank you.
No doubts about it. But what is important? Idea is idea. You cannot patent it. But maybe you must go to notarius and to put his signature, proving that this idea was applied for this date and so on and so on. At least some kind of document by somebody independent, notarius, supposedly. Maybe this is you couldn't do it 35 years ago, whatever. That's why, I don't know what to do with ideas because I am not in ideas. I am in development of cosmology. Most of them ideas, but I publish my papers. I can refer to them. In your case, there is no publication. There is no somebody official going around this, committee or around these people and to steal some ideas. It's most, I don't know. Don't want to continue this talk because even our genius people, you can go to history of our cosmology, they could steal some ideas simply without any reference to anybody. You know what I mean?
Well, in this case, it's kind of, there's some ambiguity in um, what the status of what Jim sent. If you're a researcher, you can't cite a package of information that Jim Keene sent. That's not, the rules are you have to have a published citation. Because it's not a.
I'll dispute that if I may. There's such a thing, and you'll see it sometimes as personal communication. James J. Keene, personal communication, 1989, whatever.
Right. And that's if the guy's being honest, I think is the point.
Right. So that, well, one can use the Coca-Cola model, keep the formula for Coca-Cola concentrate secret. That's one way to go. For whatever reasons, at that point in my life, I decided to send this information to DARPA as something that might be useful. And if it were of importance technologically, it would be good that the US had that advantage, or so I probably was thinking at the time. And I think I would still think that way. Why, if anybody develops a dramatic new technology and they're just going to run and send it to, let's say, communist China or whatever, that's, you have to wonder why they would do that.
Okay. Anything else?
Well, what's your interest really in the provenance of this, Jim? Is it just, it's an interesting coincidence or whatever, just you want the information, or do you want recognition? I mean, you could sue DARPA for $9 billion if you want. Is it just an academic
Really?
exercise,
I can sue them. I have to talk to my daughter about that. Well,
you might have more chance than another case which is going on actually at the same level. But anyway.
Well, as far as recognition goes, with this video today, I have the recognition. That's in the done column. With regard to any possible monetary result, well, that's something to look at. I viewed the paper for today's talk, which I actually published on my blog in preparation actually for today's talk, as a stepping stone. In other words, if anyone has information which may be pertinent to this whole story, well, now they know who to contact. Give me a call, give me an email, whatever. And what is your information?
Is that DARPA knocking on your door there?
Oh no, they're doing construction next door. a while ago, someone was running a very loud motor. And I thought, gee, that's going to completely destroy today's talk, but they turned it off.
Well, I might say that your audio is excellent today. Over the previous weeks, it's been rather intermittent, but it's actually very, very good today.
But on Zoom, I think it always is good, isn't it, Ian? Or are you just talking about the CNPS meeting?
Yeah, I wasn't just talking about the CNPS. Perhaps it has been better on Zoom, but I think today, I don't know what the others think. I think today on Zoom, it's been better than it has been in previous recent weeks.
Jim has his days. Sometimes he's okay, and other times he's a little bit choppy. And when you're choppy, James, just remember to turn off your camera, and it smooths out a little bit more, because it doesn't have to send the video information as well. It only has to send out the audio information, which is smaller packets and less packets. So.
Or don't.
Okay, do we have any more questions or comments for Jim about his presentation today?
I thought it was a pretty good presentation. I think legally he has no footing, but I mean, because he sent that out without anybody looking at it and verifying it, that he has this idea and he's going to send it out to whoever. It's just his word, basically. So.
Well, I learned something, Rick, hopefully from that episode. With binary mechanics, I mailed myself the paper written in 1996 and first published in 2010. I mailed myself a copy of that paper. Also, I went to a lawyer and had him notarize that the paper exists. And so at the lawyer's office, there's a copy of the paper,
Right.
the first paper on binary mechanics, with the lawyer's initials on each page.
But you didn't do that with the other one, right?
Yes.
No.
Yeah.
I guess with the other one, I learned that the hard way, I guess.
Yeah.
But you're saying you're really not interested in the acclaim or the money. That's the impression I got. You were basically, my father did something similar. And he worked for the government, and he had this idea. He was working in gasoline efficiency cars, how to make cars more efficient with respect to gasoline. And he had a number of ideas about this. And being a government employee or former government employee, he sent these things off to the different government agencies, and he contacted different General Motors and these different companies and sent them, his ideas and his theory. And of course, it went nowhere. And I remember asking him, why are you doing this? And he said, well, because, he felt that the world deserved this knowledge. That sounds to me kind of similar to what you were saying, Jim.
Yeah, roughly so. In other words, on neither of my websites, the blog that I showed today, the Independent Investigation of Truth, James Keene at blogspot.com to flare it again, or my binary mechanics site. On neither site do we ask for anybody's emails, or we ask for anybody's money, or send me money on Patreon or Substack.com, or I don't, I'm lucky enough that I don't need anybody's money. So and I've always just been interested in research and the ideas, and not necessarily profiting personally from them. And you might say that's sort of a dumb person. and I might actually agree with you on that. But so it is.
No, but even taking the altruistic motives, which I don't decry, uh, it seems strange that I don't know exactly what it is in the US, but on the first glance, it appears strange that you didn't send it to somebody like the Department of Commerce. Why would you send it to the Department of Defense, even though they had a research agency? It seems it might have been something to do with the Cold War or something, or your wish to help your own country or something. It seems strange that the Department of Defense was the body you sent it to.
Well, it was advanced research projects. That's DARPA. The adjective defense is tacked on there. Defense Advanced Research Projects Agency. And I thought that might be of interest to them. Apparently, it was sufficient interest to send people, some operatives to my actual house where I lived, in Puerto Rico at the time, as well as to apparently record my phone calls. Else, why would someone call and say that they're sending Dr. Keene's phone calls over? Which was really weird call to receive.
Well, I'm just getting a bit paranoid about anything with defense in it, even if it's a very fundamental research establishment. And I just think that once a citizen would send anything to them, they would, there'd be lights would flash up and they'd want to look at this and so on. And I'm just guessing now, had you sent it to some other research agency which had no defense name attached to it, you wouldn't have experienced the same thing. Nobody would have knocked on your doors. I'm just
Well,
suggesting.
my comment on that, Ian, would be DARPA was really the advanced computer technology with respect to the United States government. They had invented the internet, I think, by this time. And
Correct.
to me, that is the logical place to send it to. You'd send it to other government agencies, and that would be even, they're going like, what is this? We have no idea what this is. And they might send it back to you, which I think is kind of interesting that they didn't send it back to you. But I don't think the Department of Commerce, I mean, that DARPA at that time was the premier computer science organization in the United States government. I think that's the issue why you sent it there, Jim, right?
Yeah, I think so. And today's presentation, I asked Harry to talk on this subject. And thanks to both Harry and Roger Anderton, I wanted like a sort of a report. Today is like a report on the status of what these developments actually were and who actually did what. In other words, that which might inspire internet sleuths, which was the last paragraph of my talk, to look into this. Like, for example, exactly who was the head of DARPA and who worked in the mailroom at DARPA or whatever. Who are the people and are they still alive now? And who might they have, what did they actually do with this information? They certainly thought there was some interest in the information I sent to them, sufficient to send their operatives to my actual home to check me out, what sort of a person is Keene or whatever, and what do you see in his place, what can you determine from that, as well as recording my phone calls. And so today's talk is basically an introduction to the topic, which perhaps others with pertinent information might then come forward, because I've noticed that Roger Anderton's channel, and therefore these sessions hosted by Harry Ricker, are rather popular. There's a lot of views of these videos, and good job, Roger and Harry.
Okay, very good. I think I'd like to wrap this up if we can. Do we have any additional comments or questions? And I'd like to wrap it up.
Thank you, Harry, for allowing me to present. I enjoyed it.
Well, we need people to present other than me.